Hello guys again. We will continue our topic permutations. In last lesson we see the topic permutation of n elements. We arrange n elements among all of these n elements. Now we will see the topic permutation of r elements selected from n elements. That means here we can say shortly arrangement of r things chosen from n things. That means r is less than n, or they can be equal. Okay, so definition is here: r from n, the same thing, r is the less than n, is, we can write using the permutation in this form, p n r. That means n from n elements, we are selecting r, we are taking r. Or also we can show in this way also. In down part we have n, upper side we have r, and also we have different types of showing the same thing, permutation of r elements selected from n elements. Different books are showing the different ways. Look, p n r, a n r, that means arrangement of n elements selected from, r elements selected from n elements. All the same meanings. Okay, so shortly we can say n factorial, this n factorial divided by n minus r factorial. Okay, now we have an example here. Which example? How many different two-letter combinations can we form from the letters of the word Kano? Kano, K-A-N-O, 4 different letters, if a letter cannot be used more than once. So we need to make two-letter words, okay, or combinations, two-letter combinations, first and second. They can be ka, okay, on, no, and so on, okay, but not same. We cannot use more than once. For example, AA or KK, we cannot use this kind of things. Now, let me show using 3 ways, which we learned before. The first way. Okay, first way. How many letters we have here? 4 letters. Okay, among these 4 letters we are using, for example, in the first one, let's put, for example, K. Okay, for one of the 4 letters. Next, we cannot put, for example, if we put K, if we put K here, we cannot put in second place. So we left 3 letters. So we multiply them. 4 times 3 is equal to what? 12. It's the first way. Okay. Now, second way, we can make table. For example, we can use these letters, isn't it? Kano. Let's start firstly, our combination starts with K. Ka, K-N, K-O. Okay? First. Next about with A-K, A-N, A-O. You see? Next, let's start with N. N-K, N-A, N-O. And the last one, let's start with O. O-K, O-A, and O-N. You see? How many combinations we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see? We have here 12 combinations. So, the third way, we will use this our topic given. First, how many letters we have here? 4 letters. We are selecting just 2 of them. R is equal to 2. So, P and R, you see? That means we are making 4 from 2. That means, 2 from 4. It will be 4 factorial divided by 4 minus 2 factorial. What does it mean? 4 factorial divided by 4 minus 2 is 2 factorial. Let me open this 4 factorial. 4 times 3 times 2 times 1. 2 as 2 times 1. 2 times 1, 2 times 1 cancelled each other. 4 times 3 will be 12. You see? We can solve using 3 different ways. Okay, let's continue. We have this kind of examples. Let's calculate P 5 to 3. That means 3 elements from 5, 2 elements from 7. Let's find the multiplication. P 5 3 means 5 factorial divided by 5 minus 3 factorial. Is that? Times 7 factorial here divided by 7 minus 2 factorial. Okay? Okay, let's continue. 5 factorial we have here. We have a fraction, multiplication of fractions. We can multiply upper sides. And here we have 2 factorial times 5 factorial. Is that 5 factorial? 5 factorial, 5 factorial cancelled each other. Now, let's open the 7. 7 times, 6 times, 5 times, 4 times, 3 times, 2 factorial. Okay, I can stop it here. 2 factorial stopped here. They are cancelled each other. Then is equal to 7 times, 6 times, 5 times, 4 times 3. You can multiply by yourself or you can leave as this one. Let's continue here. Let's solve this example. We have 3 different permutations. Look, A, B, C. Let's solve A here. Okay, let us solve A. Among 7 elements, we are selecting 3. That means 7 factorial divided by 7 minus 3 factorial. I'm sorry. Let's continue here. 7 minus 3 is 4 factorial. See this equivalence. Let me open the 7 factorial till 4. 7, 6, 5 and 4 factorial. 4 factorials are cancelled each other. What do we have here? 7 times, 6 times 5. So shortly we can say 210. This is A. Let's solve B. P and N. P and N. And N. What will be? N factorial divided by N minus N factorial. You see? N minus N. What will be? N factorial divided by N minus N will be 0 factorial. You know 0 factorial is 1. So it will be N factorial. If you know from previous topic, N is equal to N factorial, shortly, isn't it? Permutation of N factorials, N elements. Next, C, P, N, and 0 will be N factorial divided by the first one, N minus 0. That means we didn't select anything. We didn't choose anything from N. So it will be N factorial divided by N factorial itself. They are cancelled. The answer will be 1. So P N 0 is equal to 1. It is. Okay. Now let's solve the next one. P N and 3 multiplied by 5 is equal to P N 4. Is given. Find N. We should find N. Now, N factorial is here. We are selecting 3 from N, isn't it? So it will be N minus 3 factorial multiplied by 5. Is that okay? Now, here we are selecting 4 from N. That means N factorial divided by N minus 4 factorial. Now, all of them have here multiplications. Now, so I can cancel these N factorials, both of sides. Why both of them on numerators and opposite sides of the equation. Now let's continue. Let me write this one. give an example. What I left here, 5 divided by, let me write this n minus 3 till n minus 4. What will be here? N minus 3 times n minus 4 factorial. I left here 1, isn't it? And n minus 4 factorial. So, the same thing, both of them on denominator, all multiplications, and they're same on the opposite sides. I can cancel them. What I left here 5 divided by n minus 3 is equal to 1. Let's make cross multiplication. It will be 5 is equal to n minus 3. So if we take this 3 to right side, left side, it becomes positive. So n is equal to 8. That's okay. You see? We found the answer. And the last one, how many 3-digit numbers can be formed from the digits in the form in the number 13,567 if a digit cannot be used more than once? So 3-digit numbers, 3-digit. We are going to make 3-digit numbers, isn't it? 1, 2, 3. Among which numbers? What's the set of numbers we have here? 1, 3, 5, 6, and 7. How many numbers we have here? 5. How many numbers we need to make? 3. So n is equal to 5, r is equal to 3. Actually, we can use this one. Or we can put how many numbers? 5, 4, 3. Or we can make as this one here, permutation of 5 and 3 is equal to 5 factorial divided by 5 minus 3 factorial is equal to, that means they cannot be repeated. So 5 times 4 times 3 times 2 factorial divided by 2 factorial. You see? Is it everything seen? Okay, they're cancelled. If you multiply them, it becomes 60. So, if you use the table method again, if you put here 5 numbers, and for example, we put 1 here, next we left 4 numbers and 3 numbers. If you multiply them, you'll get again 60. The answers are seen. You see? Okay. These are all examples for permutation of R elements selected from N elements. Now let's continue with the different thing, the same thing but a little bit different. We have a remark here. The number of permutations of R elements, look, R elements selected from N elements, is the product of R successive numbers less than or equal to n. So, look, P on R, we are selecting R elements from n, isn't it? So, if you open it, if you make, for example, this kind of thing, formula, you know the formula here from here. If you make this formula and calculate them, we will have this kind of thing. N times n minus 1 times n minus 2 times n continuous and continuous continuous n minus r plus 1. See how many factors we'll have here? R factors. Here you have an examples. Let us see. Look, we are selecting 4 elements from 5. See, 4 elements from 5. So let us solve using the same method, but using our given formula. What was it? 5 factorial divided by 5 minus 4 factorial. So it will be 5 times 4 times 3 times 2 times 1 divided by 1. Is that? 1 factorial is 1. So let's cancel them. Actually, it doesn't need this one. How many elements we have? 1, 2, 3, 4. You see? 1, 2, 3, 4. 4 elements. Here we have 4 factors. 1, 2, 3, 4. It's very interesting. The first one, let's see the next one here. Next given example, P 10, 3. That means we're selecting 3 elements among 10. 3 elements among 10. So it will be here. I'm sorry. We can say we're selecting this one. We can multiply it's given 10 times 9 times 8. Let us write this 8 as in given this example, as it is given here. Let me write this 8 as n is what? 10. 10 minus r. R is what? 3 plus 1. 10 minus 3 is 7 plus 1 is 8. You see? This is correct, we can say. So, how many factors we have here? 1, 2, 3. How many numbers we are choosing? 3. See? Here as well, we are choosing 4 elements from 5. How many multiplications we have here? 1, 2, 3, 4. For example, in this example also, we are selecting 1 from 20. So factor is 1. Just 20, that's all. Okay. Let's continue with a different example here. A fighter plane has seats for a pilot and a co-pilot, as is shown in this picture. Pilot and co-pilot. In how many different ways can these seats be selected from a squadron of 18 soldiers? Look, we should select just two soldiers to these 2 seats among 18 soldiers. So our n is 18, you see, and our r is what? 2. We should select just 2. Now we can solve using 2 methods here. 18, as we know, P 18 and 2 here, isn't it? So it will be 18 factorial divided by 18 minus 2 factorial. We can continue doing this one. 18 minus 2 is 16 factorial. Let me open this 18 till 16. 18, 17 times 16 factorial. Okay? 18 times 17. See? Now, let us use the given property here. P 18 and 2 is what? Is what here? Is equal to, we are just multiplying these 2 first leadings. That means 18 times 17. We will have just 2 factors. 2 factors. That means 2 multiplied numbers. Here we were selecting 2. We have 2 factors. You see? The same thing. And the last example, it's very complicated, we can say. At the same time, very interesting, a very useful example for you, in my opinion. What is this? A 3-digit number is formed by choosing elements from the set 1, 3, 4, 5, 7, 8. You see, all of them different, without repetition. That means we are going to make, let me show you, 3-digit number from this given set. There shouldn't be any repetition. For example, you cannot write 111 or 311 and so on. Okay, you see, one number here, 1 digit, we can write just one place. We cannot rewrite again. Okay. Now let us see how many possibles possibilities among this. How many numbers we have here? 1, 2, 3, 4, 5, 6, 7. Okay, n is equal to 7. How many digits we should make? R is equal to 3. Let's find all possible numbers. Okay, all possibilities. Okay, it will be P, 7 and 3 will be here. Now let's find 7 times. We can use this property here. We are taking 3. That means 7 times 6 times 5. What will be the answer? 210. This. So we can make, using these 1, 2, 3, 4, 5, 6, 7 numbers, just 210 what? Numbers without repetition. Okay. Now, question 8. How many numbers do not contain digit 5? Do not contain. You see? What we can say? 5 is excluded. 5 is excluded. Excluded. We are not adding 5. So how many numbers we had? 7. If we subtract, that means we exclude 5. We left here 6. N is equal to 6. Again, we are continuing making the 3-digit numbers. R is equal to 3. So it will be P 6, 3 is equal to 6 times 5 times 4 is equal to, what is the answer? What will be the answer? It will be 120. See? 5 is excluded. Without 5. B. How many numbers contain the digit 5? Now, how many numbers contain 5? It is very interesting. So we can say this 120 without 5. Is that? Without 5. All possibles are 210. That means all minus, let me show you, without 5, we can have the answer with 5, isn't it? Contains 5. So all is what? 210. We're subtracting without is 120. The answer will be here, what? Yes, 90. With 5. Contains what? Contain 5. We have numbers containing 5. Now, let's see how many numbers contain 1 or 7 or both 1 and 7. It's very interesting, is it? So, let us see. First of all, I think we have to find, firstly, let us exclude them. 1 and 7 are excluded. So it will be, how many numbers we have here? That means if we exclude, how many numbers we left here? 5. N will be 5, R will be again 3. That means we are not changing, we are making the 3-digit numbers. So it will be P, 5 and 3, isn't it? What will answer? 5 times 4 times 3, so it will be 60, isn't it? This means 60 numbers, that means 63-digit numbers without 1 and 7, or just 1 or just 7. Okay, they are not contained 1 and 7. So what we can say, the question was different. How many numbers contain? Contain means we should subtract from all possibilities. That means all minus without. It's the same with the second question, isn't it? Without 1 and 7. See? Answer will be contain. Contain 1 or 7 or 1 and 7. You see? So what will be? Here 210 minus 60. The answer will be 150. So 150 3-digit numbers contains 1, 7 or 1 7. Let me give you just examples. For example, here 134, it contains 1. For example, 897, you see, it contains 7. Or 217, both of them, it contains both of them. See, these are examples for this one. Okay. Thank you. Thanks for your listening. Okay. Our topic was permutation of n elements. Okay. R elements, selected from n elements. So I try to show the examples from your book. You can repeat all the examples from the book. Pages till 345, okay? And the homework is this one. Check yourself 85. The page 345. Okay? Thank you.